Welcome back. Today's topic is short-term price forecasting. In the last video lecture, we have seen how to plot the forward price curves, and in this lecture, we will see how short-term price forecasting is being done. I hope that by the end of this video lecture, you will be able to determine MCP and describe how it is varied with variation in demand and supply. And I hope that you will be able to describe the different methods of short-term forecasting. And also, I hope that by the end of this lecture, you will be able to describe the concept of MAPE, which we call it as mean absolute percentage error. Now, let's start with the demand and supply curves, which we have already seen in unit number 1. And we have already seen how to determine the MCP, but we will extend this concept of MCP to price movements and actual cases. And later we will move on to a simple description about forecasting methods. And finally, we will close with the concept called as MAPE. The first one, the market clearing price, has already been explained in unit number 1. It is the largest bid which has been finalized with the demand and supply bids received by the pool operator. We draw the demand curve and also the supply curve, and the intersection of these two curves gives the market clearing price, right? So normally the demand curve is a graphical representation of the relation between price and demand, the demand volume, right? So it is just like in economics, we do take this as the independent variable, and this is the dependent variable. Conventionally, what we do in our mathematics, we do take independent here and we do take dependent here, right? But in economics point of view, we do take as a reverse one. So this is the independent variable and this is the dependent variable. Okay. So in this typical representation, if you carefully see, price is represented on the left hand side, whereas demand is represented on the horizontal axis, but demand is a dependent variable on the price. Now, if you carefully see, as the price increases, you know that as the price increases, demand will be decreasing. This is a universal law of physics, right? You take any commodity, the price goes on increasing, the demand will be decreasing. Nobody wants to buy any commodity at a very higher price. So, at lower prices, the demand will be very high. Whereas at higher prices, if the price is very high, then the demand will be very low. If the price goes on decreasing, then automatically the demand will be increasing. This is your demand curve. So, on the other hand, if you see the supply curve, so this is the demand curve which I have drawn here. On the other hand, if you see the supply curve is a graphical representation. You will be having price on vertical axis, and this is an independent variable, and this is supply volume is a dependent variable. Okay. So again, we go to the economics. As the price increases, supply increases because everybody wants to develop their good and they want to sell it at higher prices, right? So as the price increases, the supply also will increase. So the curve will be like this, isn't it? So this is the supply curve, and the intersection of these two curves is nothing but here market clearing price. In electricity markets, there is, as we have already discussed, there will be two different things. One is a single or uniform price market rules and pay as market bid clearing rules. But in pool operator, what we do is nothing but we generally finalize the MCP, which is the common price for all the players, right? So how it is the lowest price obtained at the point of intersection of aggregated supply and demand curves and the volume of power, which we call it as market clearing volume, right? At this MCP, all the suppliers of generation and customers, they will be satisfied, and the trading will be done between this finalized bid people, those bids who have, the people whose bids have been finalized. So at this particular MCP, total sales bids in their merit order would be equal to the total purchase bids, and that price will be a MCP, right? So after an auctioneer, he receives supply and demand bids, he aggregates them, and he draws supply and the demand curves. We have seen them. Intersection of these will be giving your MCP, right? So this is your MCP. This we have seen up to this concept in your first unit. So if you draw this curve, this is your supply curve, and this is your demand curve, and this is your equilibrium price, isn't it? Now, if you carefully see, if supply curve is shifted upwards, what will happen? Now, I'll draw this again. This is your supply curve, and this is your demand curve. Now we will see how the behavior of this one. Now let us suppose if the supply curve is shifted upwards a little bit. See what is happening? The MCP is increasing, whereas MCV is decreasing. Right? MCP increases and quantity decreases. Similarly, if S curve is shifted downwards, what will happen? MCP decreases, whereas MCV increases. This is MCV. Okay. Similarly, if we take this one, if this is the concept, if I shift this one to left hand side, if it is shifted to left hand side also, what is happening? If you carefully see, again the MCP is increasing and the MCV is decreasing. So the S is shifted to left, and if it is shifted to right also, so this is the concept. MCP decreases and MCV increases. This is the movement of supply curve. Supply curve can move left, right, or upward or downward. Similarly, now we will see demand curve. This is supply, this is demand. What happens if demand curve is lowered? If demand curve is lowered, MCP decreases and MCV also decreases. Right? So if D curve is shifted downwards, MCP and MCV both decrease. And if it is shifted upwards, both will increase. Or let us suppose if it is shifted left hand side, then also what happens? The same thing is going to happen. So this is the concept of price movements when there is a change in supply and demand. Now you may get a question that why do these curves do change? There are different scenarios why these curves do change. Now let's see a quick look about how these things happen. So now the first one is case 1. A supplier would decrease the price. So if a supplier is decreasing the price, what does that mean? So normally this is supply curve and this is demand curve. A supplier is decreasing the price means this is supply curve, this is price, and this is supply. If a supplier is decreasing the price means what is happening? Supply is not increasing, only the price is decreasing, which means the price will be decreasing, which means the S curve is moving downwards only with respect to price. So this is a case. So what is happening now? Supply curve is moving downward. If supply curve is moving downward, what will happen? MCP will decrease and MCV will increase. Now let us suppose if the demand is suddenly increased, what will happen? The demand curve, demand volume is increasing, which means demand curve will move to the right. Now let us suppose if there is a sudden short circuit or somewhere a cyclone is happening and the demand has suddenly decreased, what will happen? Demand price is not changing, only demand curve is moving to the left side. So these are the different cases. Now let us suppose if there is a sudden change in renewable energy, and renewable energy has come into picture and most of the people are moving towards renewable energy. So what will happen immediately? The concept is supply quantity may be the same, but the cost of generation is reduced. So what will happen then? the supply curve comes down because the price is decreasing. Okay. Now let us suppose a new supplier has entered into the market. So prices, I am not talking about prices. I am talking about new generator has come into picture, which means supply is increased. If supply is increased means supply curve is moving in this fashion. It is moving to the left. So this is the behavior of these supply and demand curves for different case studies. Now, having said this, I hope you have understood now why do these curves change and how MCP and MCV are determined. Moving ahead, coming to forecasting. So, to determine MCP, we need to forecast different things. Now, the question is how we can forecast the supply and demand. We need to have very good understanding about different concepts in electrical engineering. I mean, we must be aware of the latest happenings in the electrical societies. So, after having a good knowledge, a thorough knowledge about what is happening around us, now we do have so many variables which we should process on to determine absolute supply and demand curves, right? So, one such method is simulation method. In simulation method, which basically does using computer simulations, different programs and softwares are coming into picture. So the analysis of price, varying of price volatility, you know that it is based upon the probability distribution, which we have already seen in lecture number 3 of unit number 3. And the users can determine the distribution of input variables using historical data. There are 6 to 7 variables which we have already discussed. So now, for example, providers could use a beta distribution. There are so many distributions: normal distribution, beta distribution, which requires estimation of maximum, minimum, and most likely value of input variables. So these are required. All the input variables which you choose, 5 or 6, the maximum, minimum, and most likely values are required for this beta distribution. So to capture the effects of uncertainty, samples are drawn from the distribution of input variables using Monte Carlo methods, and a scenario is created. And for each scenario, a particular tool is being used for simulation of market prices and running different number of scenarios which we have already discussed. It produces now a stable distribution of long-term market prices. And based upon that, the volatility indices and traditional measures are then developed in order to get a statistical distribution. So this, after having this forward curves and understanding this price volatility, then we can think about the risk associated with the participation in the supply markets. So simulation method is one of the easiest things if you are well good with this simulation softwares. And if you do have abundant data regarding the input variables and that maximum, minimum, and most likely values, you can employ the simulation methods. The other one is nowadays artificial neural networks has come into picture, where so many algorithms have come into markets. So it is something like ready models are being applied now. So it is very easy to implement, and it is giving very what I mean to say, very close to actual values. So earlier it was used to apply for we use it to apply it for load forecasting. Nowadays we are trying to understand the prices also, how they are varying. We are employing it to determine the price volatility also. One such software, see, artificial neural networks is just a methodology. So we do need a software to run this artificial neural networks also. So normally we do employ MATLAB. MATLAB is one of the powerful tools which electrical engineers do employ. So that we will discuss in our course project, how to employ artificial neural networks with MATLAB for price forecasting. I have mentioned a reference for you. You can go through this reference for more information on this one. Okay. And the closing, I will be closing this with a term called as mean absolute percentage error. What we call it as MAPE, which you see most of the times in stock markets. I'll just give the definition. The detail we will discuss in the class. Now let us suppose this is an actual value and this is the forecasted value here. So percentage error is determined using this particular formula. Once you determine the percentage error, then absolute percent error is whether it is positive or negative. Sometimes the forecast value may be higher or lower than the actual value. So when you determine the percent error, you take the absolute percentage error. And if you do have a number of estimates like this one. So for each of the estimates, you calculate APE, and once you calculate the APE, you determine the average of all these things, and this is nothing but a mean absolute percentage error. So for any single variable, the forecasted values may vary, and based upon that, the MAP will be varying. Okay, MAP is generally widely used to evaluate the performance of load forecasting. However, in electricity prices, MAP is sometimes not considered as a reasonable criteria, as it may lead to inaccurate representation. Normally, if the actual value is very large, now as already I told you, MAP is nothing but it depends its function on APEs, right? So if you do have n values, then right. So let us suppose P, we know that V is forecasted value minus. Now let us suppose if this value is actual value is very large and if it is very small. So what is the difference between these two? It is very high, and it will result in percentage error is equal to 100 you will get. So which means that your MAP also will be somewhere near 100, which is not actual. Let us suppose if the actual value is very small and this forecasted value is very large, then automatically what happens, this PE, it will be very large value. So like this, MAP generally is not suitable for electricity prices or if the volatility is too high. Okay, and one more thing is if the actual price is 0, then you can see that percent error is infinity and MAP is also infinity. So that's why we must be very careful when we are employing MAP for price volatility. Okay, so one of the proposed alternate for MAP is determining the average value. So average value can be used to avoid volatility problem. So this is average value. Actual values itself are averaged first, and then this V bar is used here in this case. Earlier we used it to do it directly, right? So now what we are doing is nothing but here instead of direct value we are using an average value. So the rest remains the same, mean absolute percentage. Okay. So I hope now you are able to estimate the variation in prices for different situations, and how supply and why supply and demand curves will be varying left to right or bottom to top. And I hope that now you are able to understand clearly the concept of MCP, and I hope that you will be able to explain the different case studies and how prices will be moving. And I hope that you are now capable of explaining me the different methods of short-term forecasting. And don't forget to watch the literature which I have given you, how to employ MATLAB and artificial neural networks for price forecasting. And I hope that you have understood the concept of MAP, and we will try to apply this MAP in our problem in the regular class. And these are the short answer questions which I'll be asking you. That's it for today. Thank you. Yeah, I would like to mention that this is the last two references which I have mentioned. You go through them, you'll find the applications of MATLAB. Okay, thank you.